In this video, we're just going to take a few minutes to look at what HPLC and GC chromatography systems look like. So here is high performance liquid chromatography, HPLC. Now this is just liquid chromatography that's typically gravity fed, except the system is pressurized. And so the flow of our mobile phase through our stationary phase is faster and has greater control. So our overall systems can look something like this, or usually they can be self-contained. And what it's going to require is this vacuum pump right here. The vacuum pump is what is going to put pressure on the system. And it's, to move things through it. And we'll have a high pressure pump that really increases the pressure. And so we're going to have these solvents right here. These are going to be our mobile phase. Our stationary phase is right here in our analytical column. And our sample is going to be injected in right here at the beginning of that stationary phase, or the analytical column. And so these solvents are going to be pumped through, so it's going to go this way, through our sample injection, where our sample is injected into this analytical column, and then through that stationary phase in the column. And then as compounds come out, they're going to go right into a detector before they come out. And for, we call these fractions of our sample as they come out when everything is the same identity. And then when it changes to a different compound, then we're in a new fraction of our mixture. And then a detector may be a couple different styles of detector, but it's going to give us information about the identity and concentration of the compounds that are coming out at that time. And then we'll be able to determine what those are and their concentration. And this is how we can separate different cannabinoids from one another through the column. So these are great because they're faster than just gravity liquid chromatography, but also there's a lot of control once you automate it. So that way, so you have control over the pressure, but also you have a lot of control over the system, which allows for great separation. And so it's, I think, one of the more common methods that are used for that reason. And they can be automated. They aren't too labor intensive to run. However, because we're putting these compounds under pressure through these systems, it doesn't work great for identifying really volatile compounds that like terpenes or residue solvent. Those can be harder to detect because they're less likely to be in the liquid phase. And so gas chromatography is used for things that tend to be more volatile. But it also has its own limitations. And so here's what gas chromatography looks like. And in this case, what we have is we usually have our mobile phase here as an inert gas. And we have to have a big container of it. And so this gas cylinder feeds into our column. And so our gas for our mobile phase comes in here. And then here's where we inject our sample. And we usually use the smallest syringe you've ever seen, because you use a very, very small amount. And when you put it into the inlet right here, it's going to vaporize your sample, and it's going to be bringing in the gas at that point. And then it's going to feed the inert gas and the vaporized sample into this column. And it's going to have a temperature control, so it'll be heated to keep everything vaporized. And then it's all going to go through this column, which will take some time, and then come out to a detector. Again, this will need to probably be like a mass spectrometer or something else. And you'll be able to take that detection data and determine the identity of the compounds that came out first, second, third, fourth, and their concentration. With this, so because we are vaporizing our sample, this works great for smaller compounds that have less molecular weight. So really, really, really big biomolecules are really hard to vaporize because they're just so big. And so smaller compounds work fantastic with gas chromatography and things that are already really volatile, terpenes or solvent. And so gas chromatography is another technique that's used quite a bit, but another interesting thing you can do using gas chromatography is actually, instead of taking a liquid sample, take a sample of the gases above the surface of a liquid sample, so you can get the volatile compounds that are already in the gas phase, and inject those into your gas chromatography setup, and separate those and see what was present in the vapor above the surface of a sample that's made out of liquid. And so gas chromatography is a great tool for using for smaller compounds that are already volatile. And it seems to be used less than HPLC. It is a lot more work to maintain these very thin columns in the gas chromatogram or gas chromatograph. And so there's also a lot less variability. It's more work to change out the column than it would be to do for HPLC or liquid chromatography. And you have less tunability for your separation because you're using an inert gas rather than using your mobile phase to also participate in the separation by interacting with some compounds better than others. Regardless, when you use gas chromatography or you use HPLC, you do need a detection component as well. One of the ones that is really common is mass spectroscopy. This is used to identify or confirm the identity of a compound. And really, with mass spectroscopy, we're measuring the mass and versus the charge of something, and compounds are basically ionized and fragmented into ions, and then they're accelerated, and so they separate because of their mass. The differences in their mass will lead them to move faster or slower. And then a detector is reading the mass and charge and then identifying these fragments, and the pattern of the fragments allows to identify the compound that they were originally. There are other methods, though, for identifying compounds. Flame ionization detectors are also used, or atomic absorption, UV vis spectroscopy, and MR is less common. And a lot of our chromatography equipment is coupled to these. So you'll see GCMS, so gas chromatography mass spectroscopy, as one unit. So you perform gas chromatography to separate, and then it goes right into a mass spec that allows you to identify the compounds that you're working with.